Bismillahirrahmanirrahim. Hello everyone. Today I want to discuss about a triple H updated question. This question asks about how to improve power factor of a system using synchronous motor. So let's discuss about this question. Assume that this is a industry. So this industry having inductive loads. This is the summation of all inductive loads. So these loads having lagging power factors, so it will deteriorate the power factor of the system. So to increase the power factor or to improve the power factor of this industry or of this portion of the system, we use a synchronous motor. So this is total real power and total reactive power coming from the bus to these loads. So uh, inductive load having P1 as real power and Q1 as reactive power, and synchronous motor having P2 as real power and Q2 as reactive power. So if we want to use synchronous motor to improve the power factor of the system, then the Q2 must be negative. So if Q2 is negative, then it means that it is supplying reactive power. And as you know that if you want to increase the power factor of a system, we have to supply reactive power. We have to supply sufficient reactive power to this system. So let's discuss about how can a synchronous motor can improve the power factor of the system. So this is the phasor diagram which will prove that how a synchronous motor can supply reactive power to a system. So assume that the terminal voltage of the synchronous motor is Vt. So we are supplying Vt to synchronous motor, and E1 is E. This E1, E2, E3 are the induced voltage in synchronous motor, and these are the armature current of this motor. So as you can see that if we increase the field current, that means we want to increase the field current of the synchronous motor. So if we increase the field current, so the power will not increase. So the E1 sine delta or I cos theta, which indicates the real power giving by the motor, should be constant. So as we increase the field current, then the flux will increase. So as a result, we can say that E is proportional to, we know that E is proportional to phi, and again phi is proportional to IF. So if we increase IF, then E will increase. This is actually IF. This is field current. This is the field current of synchronous motor. So if we increase the field current of synchronous motor, then the induced voltage in the synchronous motor will increase. So as we have said that if we increase the field current, the total real power supplied by the motor will not increase, but the reactive power will increase, and the E sine delta and I cos theta should be same or should be constant. So as E is increasing, so E can only increase by sliding out through this red line. As a result, the E sine delta, which indicates, E sine delta means this portion, which indicates the real power, will not increase. It will be constant. Again, I cos theta also indicates the real power. So I also slice down through this red line, and I cos theta is also constant. So in conclusion, we can say that if we increase the field current, real power supplied by the synchronous motor will not increase, only the E1 will increase, and it will slide down through a constant real power line indicated by red line here, and the I also slide down through this red line. But notice that when we increase the E1 from E1 to E5, then you can say that I is increased from I1 to I5. And you can notice that I1 is initially lagging. So synchronous motor behaves like an inductive load. So when IF is sufficiently small, synchronous motor behave like an inductor because its current is lagging the voltage Vt. As we increasing IF, the ion initially decreases, but it is less lagging gradually, and at one point I3 will be in phase with the terminal voltage Vt. In this point we can say that the synchronous motor is operating in power factor 1, in unity power factor. After this point, if we increase IF or field current further, then the armature current will increase further and it will start leading the terminal voltage. So if we increase IF again further, I will increase further and it will more and more leading the terminal voltage. And in that point we can say, we see that the synchronous motor behaves like a capacitor, because this is a phase diagram of a capacitor and resistor combination. So in this case, synchronous motor will supply reactive power to the system. So actually, if IF is sufficiently small, synchronous motor is operating in under excited condition, and if IF is sufficiently large, then it is synchronous motor operating in over excited condition. Actually, to improve the power factor of a system, we have to operate the synchronous motor in over excited condition. So now if you see the curve of IA versus IF, you can see that if we increase IF, IA initially decreasing, and after a certain point it will increase again. So before this point, the synchronous motor behaves like a lagging load, like an inductive load, and it is actually a lagging load. And after this point, synchronous motor behaves like a capacitor resistor combination, so it behaves like a leading load. So to have a power factor correction of the system, we must operate this synchronous generator in this region. Okay, now this is the answer of this question. So hope you enjoy this. If you find any mistake in this video, please comment it below. Inshallah, I shall correct it for later videos. Thank you for watching.